Hello viewers, welcome to my YouTube channel. My name is Oluwashino Oyeniro, and in my video today, I will be talking about graphs. Uh, Graph in Python, there are so many ways to deal with graph, but today we are going to be talking about the Dijkstra algorithm. So what does this algorithm do? It's a kind of method for finding the shortest path from a starting point of a node to all other nodes in the graph. Think of it this way. You have a map of a particular city in your hands with many streets. So instead of trying to figure out the best route by try and error, you can have a map that tells you the quickest way to reach your destination. The same thing is applicable here. If you look at the graph I currently have, I have A, B, C, D. I want to regard A, B, C, and D as the city and the figures between them as the distance between each city, which implies that between A and B is 1, between B and C is 2, between C and D is 1, between B and D is 5, and between A and D is 5. So how do we navigate this uh, without wasting time? So the best way to deal with this uh, is to implement a kind of a mini queue or a heap. But before then, you're going to discover that this Dijkstra algorithm it uses a priority queue to expand the node with the current known shortest distance. So it's going to start from here and it's going to say, okay, how many distance do we have between A and B? So, okay, the first thing is that from A itself to A is 0. So there's no distance. It's not distance from itself, but between A and B is 1. So this is what is going to do. Okay, let's write a kind of code to determine the shortest path, but we already know the current distance that's from A itself is 0, and from A and B is 1, and so forth, and so on and so forth. So let's say I have a snippet here that can deal with that. I have a snippet here that can give us the distance. Let's see. I will be explaining the code to you afterward. Okay. Alright, this is my snippet. I still have this. If you look at this, let me minimize this. I'm going to minimize, give us a kind of visual representation. Now, if you look at this graph, so I want you to compare it with the code. And now what are you doing? Okay. I don't want it to be too big. Oh, okay. Now, from here, I want to show you how I implement the graph. Now, we have A, and from A, you can go to B. So if from A, you can go to B, we have 1. And from B, you can still go to A, which is 1. But don't forget that from B, you can go to C as well. And from C, you can go to D. So from A, we have B and we have C. And from B, we have A, we have C, and we have D. These are the connecting nodes. From C, you can still go back to A, you can go back to B, and you can go back to D. And from D, you can only go back, from D, you can go back to B, C, and of course A. So if we implement this, what is going to be our result is going to give us the distance between each part. And this is how you are going to traverse uh, the graph. Now, what is the summary of the whole thing? That is that we have node A. Let me show you that again. We have node A. Node A is at a distance of 0 from itself. Now, the shortest path from A to B is 1, which is the kind of direct angle. You see, is a linear. Now, the shortest path from A to C is 3. That is 1 plus 2 is going to give us 3. That is from the field where if you are taking the 2B. And the shortest path from A to D, the shortest path from A to D is 4. Via C. A, which is 1 plus 2, then plus this one to get to D. And that is how this algorithm, this is how it will work. So if you have any question or you don't understand what I'm saying, you can put your question on the comment section. I'll provide answers to it as soon as possible. I would like you to share this video, subscribe to my channel, turn on the notification bell. Until next time we meet, do ensure that you are good and take good care of yourself. Enjoy your coding life. Thank you.